Today we're going through the additional math paper 2, syllabus 4049 paper 2. So this is the O levels last year that any students have did, and we're going to go through this paper today. First question. Okay, first question is basically your exponential question. So this question usually comes out in the O levels many times, so you will probably expect it this year also. So yeah, let's do the question. So you will write this formula here. Okay, copy this formula. Yeah, what in every question they give this formula, so just write down the formula first. Okay. Now copy. Okay, now first, then they say where k is a constant after 12 months. So after 12 months is basically the time, so t is equal to 12 the time. So we just need to see that if it's given in months. So let's see, t is given in months. Okay, sometimes the question may confuse you and say years. Okay, sometimes, but this question didn't confuse you, so it's okay. It didn't give tricks. So okay, so it's months, so you can easily write. If it was years, then you have to write 1. Okay, now let's sub in the values first. Okay, so let's sub in the values. Now before that, the value of the machine had dropped to 1000. Okay, so 1000. So this is the value. The v is your value of the machine. So v is the value. It dropped. So you sub the value inside. So you basically have to find your k first. So to find your new value, okay, this is asking you to find your new value. Okay, so let's rewrite this. Okay, now this is your exponential. Okay, so 1000 so you learn on both sides. Of course, you have to learn on both sides to get this. Okay, if you learn e, this is cancelled. Okay, whenever you learn e, you become 0. Okay, now I see 0, it will become 1. Okay, so to find this, now easy, just do switch it and divide by this whole thing, and you get your answer for this part first. Okay, now they're asking you to find the first machine of 25% of the purchase price. So this is basically a bit of e-math involved. Okay, so your 25% must multiply your actual price of the machine at first to find the first value. Okay, so let's subtract that first. So 450. Now 450 is your that value that dropped. Yes, correct. Value is C. Manager purchases new machine when so E T is unknown, so you're basically finding the T basically. Okay, so short form, let's find the T. You'll probably know this. Long on both sides, and it's now the long one. So 28 point. So basically they're finding this is the time, right? So there's not, so we see here always 3 sig fig. So I'm going to write the months. Now this question is basically your quality question. Okay, your quality question that comes out almost every year. So first they give, see, let's read the question first. Find the range of values for a constant k for the line y equal to x kx intersects the curve at yx squared plus 3kx plus 2 minus k at two distinct points. This is the main thing, two distinct points. What do you mean by two distinct points? Basically more than 0. So more than 0 meaning, let's this is in intersects the curve. So let's do our simultaneous equations. Okay, so sub in this bracket for now. Yeah, so when you minus it off, so you'll get this. Okay, basically just this one is this. Okay. Why I bracket this is because to make sure that I don't mix up this and this. Okay. Remember they equal to 0 at first, okay? Because we're doing simultaneous. Now we have to see b squared minus 4ac is more than 0 because two distinct points. Okay, 0. So you sub b. This is the b. This is the a, and this is the c. So okay, square a. 0. Okay, so you'll probably get a quadratic equation. Okay, so now we will simplify it to get a nice k square plus k. So factorize this, you'll get this. Okay, curve, you will draw this, and because 1 and 0 that, and so it's minus 2 minus 1, sorry, plus 1. I write plus 1, but okay, sorry. Okay, so 1. So everything is above the axis because it's more than 0. So above, done. Okay, done. Now, next question. This is the question that doesn't come out. It usually comes out in prelim papers. So let's go on and do the question. Okay, this question is not that hard. It's still relatively easy for 5 marks, honestly. So let's do log. Let's copy down the equation first. Okay, copy down. Okay, let's copy down the equation first. It's easier to see your own things. Now, what will you do for this? What will you do? Okay, so basically, right, you change this into log 2 because this is also log 2, right? So because this is log 2, so you change this to log 2. Okay, log 2. The first part the first one will be this, always. Okay, the lower part will be always this. Okay, you don't really need to write bracket, but yeah. Okay, now just write this Okay, now before that, right, before I write this, if you move this to here, what will this become? The power up rule. So this is the power up rule. So 2 to 3 is 2 to the power of 3 is 8. So we can write as like 8. Okay. So okay, now do our log rules. This can become this will become, okay, let me show you. This will become 2 to the power of 2. Okay, 2 to the power of 2 because it's 4. So this one can be cancelled. Of course, this one can be cancelled. And you write this as log 2 over 2 in h. Okay, now what is this now? Okay, now this one is pretty easy. Okay, can change this to, this one is the 2, right? So you just flip it, and this will become this. Understand? Okay. Now this one, right, log, this one is your log, anything log 8, both same. What will become? A 1. Okay. So now, so we later combine this. Let's combine it. Okay, combine, because combine how? We use the, because this is a minus, so we divide. Okay, divide, minus, we divide. Okay, divide because it's a minus. It's okay. To simplify it more, all I like to do is this. I like to do this. Yes, this is way simpler. Now, to make it go easy, so we do this. Okay. Now, power up rule. What do you get? Push soccer rule. The soccer rule, basically, I call it. So 1. Okay, this will push here, push to 1. Okay, done. And you get this. Okay, you get this basically. And so if I simplify it more and more, so then I'll easily get I'll end up, okay, you can do the rest to end up getting a quadratic equation. Okay, this is simple. Get a quadratic equation. Now, this is the main part that students get stuck. Okay, people do not remember to reject this value, because if you sub negative 2 back to x, you won't get the same answer. You will get some random value. Okay, you'll get some error. Okay, sub 6, you can get the answer. So a lot of students don't write reject. If you don't write reject, minus 1 mark. So remember to write the reject always. Do not write any, because any doesn't sound that you're rejecting the value. It's not the same answer. I mean, you can write, but I don't know about Cambridge. So yeah, just write reject. They ask you to write reject, just write reject. Okay. A lot of students really missed on this. Now let's go on to this question. This question is fairly simple. It's fairly simple. It's nothing out of the extraordinary. Okay, so this is you to find the gradient and sub that this x to find the actual gradient. So basically the actual gradient. So what do you do on this? This is your quotient rule. Okay, this is the quotient rule. So let me do this. Okay, do it. Let me show you simple. To simplify it for you, just tell you that dy dx can be written as, okay, so 4 x plus 4 So how did I do this, right? Basically is I write u and v here, so basically this v here, and I just differentiate this one part only. So to make it simpler, let's differentiate this part first. Just minus 3. Okay, so how I do it is when it's product rule, I do this first, then this first. Now if it's quotient rule, I do the opposite. I'll do this and do this. Understand? Do from the left to the right. If it's product rule, I do from the left to the right. Okay. For quotient rule, I do it right to the left. So something like that. Okay. You have to do some practice to do it. I can't tell you on the screen. So let's do get this. Okay, simple. So 5 minus 3x square. You get 20. This, yeah, basically you get this. Get this. So gradient. Okay, sorry. Okay, this is the answer, but so gradient. Now, say x to find the actual gradient, a number. So okay, I have space, but okay, I'll cancel this. Sub x1. You have to do this in the exam, okay, by the way. So that they will give you the marks. Okay. Answer is cos 5. Okay, so my answer. Easy. Okay. Now this is the question that okay, this is the question that defines the, you know, A students and the B students. Okay, how? Okay, so now why doesn't have stationary points? Okay, so why doesn't have stationary points is, okay, stationary points is basically dy dx equal to 0. So let's do this. Dy is 0. Okay, this is the gradient. Okay, we got this. Okay, so okay, then to an equal sign. Not equal sign. Okay, equal to 0. Now, if you multiply this, so this times this, you will first you get 0. Okay, 0 times anything is just 0. So you get 0. But does this make sense? No, this doesn't make sense. Since 20 is not equal to 0, therefore copy. The curve has no stationary points. Okay, simple. Okay, this is very simple. Okay, you just need to use some knowledge from stationary points. Okay, this is the not hard explanation question, so you don't need to get worried that much. Okay, so next question. This is it's just connected to the first question, but a bit harder. Okay, basically the curve y equal to x is such that f, the small, okay, what's this called, is the, so basically I always call this a reverse differentiation. Okay, so you have to basically reverse differentiation meaning integration. You have to do your integration if you see this. Okay, basically they are saying that I already differentiated it, but I want the differentiated version now. I already differentiated it, but I want the normal one back. So basically the y equation back. So now, okay, so just normally just do integration. Okay, 4 cosine x squared dx. Okay, now this one, right, is very careful. Okay, you have to carefully do this. Okay, this is very what I call it, it's a very insane kind of step. So a lot of students didn't know that year that you could have done this. Okay, pull out the thing. Okay, then you get 1 over cosine square x dx. Okay, simple now, sure. But a lot of students didn't know that they can change this into secant square x. A lot of people are stuck here and they didn't know how to do it. Just when we started subbing this equating into this, and yeah, they all went all wrong lah. So yeah, there's nothing can be done from there. If you are stuck there, honestly, if you're stuck there, you can't do anything. So now when you change this into secant square, okay, this is basically the identities. Okay, the identity. Okay, so you change the secant square. So if you differentiate secant square, what you get? Tangent square x, tangent x. Okay, so simple. Tangent x plus c. Remember to put your plus c. Now, yeah, this is basically the curve passes through these points. So f, right? F pi 4 the x. So we start with x first, okay? And there's y 1. You really find your basically. So this is y basically. So okay, simple. Okay. I'm gonna try equal first, but try this, but then okay. So I like to write this. Okay, for tangent this one plus c equal to 1. Basically you have to find your c. Okay, so on this manipulation and all, see tangent, if you type it this into the calculator, you get a beautiful 1. So yeah, c is equal to -3. So your answer, you don't usually, okay, sorry, my mistake to not write this or this, so that to ensure that the marker knows where to find answer. Okay, so fx x -3. This is your final answer. Just box it up to let the marker know that this is the final answer. Okay. Next question. Now, this question was also a very odd question that came up of this. So they're saying this is the equation of the curve. Okay, this is the equation of the curve. Okay, it's not really hard, but it's just a bit unusual because they use the word verify, because you have I don't really see a word verify before in an exam, so it's like verify, so it's a bit confusing for a lot of students. So basically what you do is differentiate first. Okay, just differentiate. If you don't know anything, just differentiate. Okay, you at least can get 1 mark from here to differentiate. Okay, so if you differentiate, ln x is, sorry, exponential x is just exponential x. Okay, nothing changed. And you send this just 1 here, and you become this. Done. So this is the differentiated version. You get a 1 mark first. Now, how did I get this? Okay, let me change it a bit. Okay, let me change up the equation a bit, yeah, to make it a bit simpler. Now, what do you see here? Verify that the curve has a stationary point at x equals to 0. So x equals 0, right, basically is, okay, to be honest, right, let me check the calculator first, yeah? If it can be done. Yeah, I'm pretty sure it can be done. Okay, it can be done. So So when x is equal to 0, basically 0, therefore curve is just copy this. Okay, to make it more simpler, right? Okay, to make it more simpler for you to understand, you can actually do this. Okay, to your normal EMAth or your primary school method. So basically make the denominator the same. So make the denominator the same is basically you get this. Okay, you get this, and you also can do that from there, and you will get the same thing. Okay, so this is the question that a lot of people missed out, that they got the differentiator version. A lot of people got the differentiator, but they didn't know what was this x equals 0. You just sub in x equals 0 to get the answer and verifying it. Yeah. Now, no. This question is your question that usually comes out every time you change your exponential to a logarithmic form. Okay, logarithmic form. Okay, your exponential equations, my bad. Okay, so just copy down the equation first. Copy. Okay, 2.9 is very weird, honestly. 2.9 is very weird. I didn't expect 2.9 to come out. Okay, as usual, we do this that we done for just now. Okay, so so 2.9. A lot of people, right, how they do it, right, is what they did, right, is okay, let me show you. Yeah, they knew that they had to do it here, but they didn't need to have done it here. So a lot of people really actually know how to do, but they just see the verify and they just give up. Okay, so I'll give out on questions. Okay, so I'm gonna make it smaller because I have no space. Okay, so let me write again. This one. So x is 2.9. Okay, a lot of people really, and during the exam I heard, right, they change this to an actual number. They change this into an actual number so that they don't think that they cheat on their calculator. So what I mean is, okay, so square x e square. Okay, this is very messy if you think about it, but it's actually quite simple, but it's just a lot of exponential things going on here. Okay, so let's see. Okay, so now you get this. Okay, very awkward, right? Yeah, very awkward. So you can't see a quadratic equation with a decimal. So a lot of people, what they do that year is they kind of times something to get a beautiful number. Then they did the exponential. I mean, you can, but it was not necessary in this question because the question really gave you a 2.9 there. So probably the examiners know that you already have to cheat with your calculator. So it's no point. Okay, just do it. Okay, just do it. Don't care. Okay, so as usual, I know that you won't really get this here. It's not mathematically correct. It's not mathematically correct, but do this. But honestly, to this question, it was allowed. I'm not that sure, but a lot of teachers say it was allowed in that year. In that year, it was allowed. So yeah, no idea why Cambridge gave 2.9, but that's weird. It should give a better number, like 3 or something. Why 2.9? I have no idea. The Cambridge marker wanted to play, but yeah. So okay, so by the way, we get this really right. So we just need to ln it, and yeah, that's finished. Okay, ln and x ln 4. This is the answer. Okay, by the way, you don't need to do the decimal. Okay, by the way, right, you don't need to do the decimal place. No, you need to convert into a decimal. No, it's okay. This is enough. This is enough. Okay, and then we'll reject any values here. Okay. Okay, next question. Your next question basically is your polynomials. Yes, it's polynomials. So polynomials, right? This one is your normal question. Okay, you get this every year. And last 2023, this question that came out. Actually, not 2022, 2021. All these questions came out, and this question is very popular in prelim papers especially. So now, so let me do the question first. The expression x cubed plus x squared plus ax plus 2b and x cubed plus 4x cubed is 4x squared minus 8x plus b, where a, b is constants, both have a factor. See, this is good. See, both have a factor of x3, so you don't need to, there's no different factors for different equations. No. So it's just same factor for both. So you don't need to use different factors for anything. So that's simple. So you have to just use one factor. So yeah, you don't prove it as a factor. Some questions need to prove it as a factor, then you can use it. This one is just told you straight away that it's a factor. So you don't need to do anything. Okay. Now, for me, right, because now I have no space because I'm using a pencil, online pencil. But for you, right, I recommend to write down the equations one by one by writing fx. Let fx, okay, let fx be this, let fx be this, okay, so that you clearly understand what is going on. Okay, you will not understand from the paper itself. It's not that easy. So for me, I have no space, so I'll just write x equal to let x equal plus 3 equal to 0. Okay, so let x equal to minus 3. So this is the factor. Okay, so you sub this inside this and this, inside this, okay, to get your equations. Then you, as usual, you do simultaneous and get your a and b. Okay, now let me do. You can pause the video here to just do yourself and see if you get it correct. So I'll do this. This is for the first equation, by the way. And also, sorry, if you write fx here, please don't write fx here again. Sorry. You can write a different equation. You can write gx. Yeah, you can write gx. Because you're not saying this. Basically, if you write both fx, you're just saying that both equations are the same, but in actual they're not the same. Okay. Just write this. It's a very long-winded question, but it's quite easy. It's just using it's not really long-winded, but it's a lot of steps but involved. But I'm not gonna lie, it's quite simple and straightforward. It's not that difficult. For me, I'm just rushing through because I don't want you to waste your time doing all calculations. So yeah, basically this is equation 1. Okay, cancel the equations. Okay, I recommend you not to write equal to two equal signs at one line, because sometimes the marker may say, oh, you're writing two equations, so I'm going to minus marks. Two equal signs at one line. So it's a mathematical error, to be honest. But honestly, in some schools, they don't really enforce that. Some schools enforce that. I don't know why. Honestly, I don't know why it's not enforced in every school. So yeah, I seriously don't know why. Yeah, okay. Sure, cancel this, and this is your equation 2. Okay, equation 2. Now simultaneous, and okay, I'm not going to do simultaneous. You can do it yourself. Simultaneous. Okay, simultaneous. Sub 1 into 2, or either ones, and you'll get your a will probably get minus 4. Okay, simultaneous, you'll probably know it because this is basically the same thing as EMAF. Okay, EMAF. If you're taking EMAF, you probably know very well for EMAF. Yeah. So now this question. Okay, this question easy. Okay, don't need to think so much. Okay, trust. Okay, basically asking you. Okay, basically solve the equation of this using the roots. Okay, now when you see roots, you know that there's something involving quadratic equations. There's something involving quadratic equations. Your b square minus 4ac, not the b square minus 4ac, the minus b plus minus, but b square root of b square minus 4ac divided by 2. That is your idea when you see roots in exact form. Okay, now let me write this. Okay, let me write it as small as possible so I have space. G, okay, G. Okay, 2x. Okay, now you can do anything you want on this, but honestly, right, what to do is just try to. Okay, you can really randomly just type anything like capital C, which is a factor, so that you will know how to do it. So that you can do your long division and all. But I'm not going to do long division here. I was going to take the whole paper. So yeah, long division is very easy. Okay, long division is basically what you have learned in primary school, but it's now in Amath form. Okay, so try to square 2, so you just sub 2. You can sub actually anything inside just to see that it's a factor, but for me I know already what is it, so yeah, so you get 0. So x equal to is is a factor of gx. Okay, now write this to show that this is a factor. Okay, okay, now this one. Okay, now to me, what's C? Okay, see this? You're basically doing a bit of partial fractions here, so just letting you know that it's a bit of partial fractions here and there. So yeah, you can do long division also, doesn't matter, but for me long division is sometimes a bit risky if you do an exam fast. So yeah, for me, okay, I'm okay with long division also, because long division is quite safe also. Actually, it's the safer one of this. And this one you can't factorize, you have to use your, and you can't, when you factorize you must get a actual value, you can't get a decimal. And please do not do like this question, it's not actually this question, don't do it like this question, okay, like what I did here. Okay, please don't do it, because it's only for that question. I have no idea why they give that, but yeah, exceptions. Okay, so yeah, sub, you get, end of the day you get this. Okay, it is, and the third form is x equal to 2 7, sorry, 7. This is one answer. Please write the barrier here if you have no space in the exam, please. Or that's 2 minus 7. So yeah, this is the thing. Okay, right? Which questions you have? No questions. Okay.